Algebra 3, Prerequisite Chapter, Section 6, the Rectangular Coordinate System and Graphs. You may remember, usually the horizontal number line is known as the x-axis, while the vertical number line is known as the y-axis. There may be times when these are renamed to fit a particular problem, but most of the time this is what you're going to see. The point of the intersection of the two lines, as we have said, is called the origin, and we have the quadrants. Each point corresponds to an ordered pair. Ordered because it always is in a particular order. X comes first, followed by y. And these ordered pairs are also called the coordinates of the points. The x-coordinate represents the directed distance between the point and the y-axis, while the y-coordinate represents the directed distance between the point and the x-axis. Notice the word directed. That's because the numbers come with a direction, either a positive or a negative direction. Now you'll note that the way we write the point, the parenthesis with x comma y, is very similar to how we represent an open interval on a number line. We use the parentheses and then we put the comma between the two numbers. How do you know which this is? Well, it's the context of the problem. It should be pretty obvious whether we're talking about an interval on a number line or a point on a plane. So here's an example. What I want you to do is to sketch a graph and plot the points that are given to you. Pause the recording, try it out, and then resume recording in order to check your answer. Here are the points. The dotted lines are showing you where they are in relationship to the x and y axis. Check your answer, see if you got it right. Make sure you follow the positives and negatives correctly. That can be very tricky, even though this is not a very complicated problem. So using the Pythagorean theorem on these sides, we have that the diagonal, the distance we're interested in finding in squared, is the difference in the x value squared plus the difference in the y value squared. Okay, to get d, what we're interested in by itself, we take the square root of both sides. And then you'll notice that they drop the absolute values. The reason for that is that when you square a number, it's going to become positive anyway. Two positives multiplied give you a positive, two negatives multiplied together give you a negative. So you're squaring a number, it's always going to come out positive. So there's really no need for the absolute values in there. So we get that the square root of x2 minus x1 squared plus y2 minus y1 squared is going to be the distance between the two given points, and that's our distance formula. You may remember this from previous years, but that's where the distance formula comes from. Next, we have the midpoint formula. The midpoint is the point in the middle of a line segment. And so what you're going to do to find this is, well, kind of what you do to find the midpoint of anything or the mid value of anything. You're going to average the values of the respective coordinates. What I mean by that is you're going to add the two x values together and divide by 2, and you're going to add the two y values together and divide by 2. Now keep in mind the midpoint is a point and your answer will be a point. You will have an x and you will have a y. Okay, try this example. See if you can find the midpoint of the line segment containing the points, joining the points, -5, -3, and 9, 3. Pause the recording to try the problem. Resume the recording to check your answer. All right, here's our solution. Really, again, we're just plugging things into the midpoint formula. We're going to add the two x values together, -5 plus 9, and divide by 2. We're going to add the two y values together, -3 plus 3, and divide by 2. That gives us the point 2, 0, and you can see in the illustration how that falls right in the middle of the two given points. Okay, our final example is a word problem. A football quarterback throws a pass from the 28-yard line, 40 yards from the sideline. A wide receiver catches the pass on the 5-yard line, 20 yards from the same sideline as shown. How long is the pass? So we have the football field. We also have it placed in a coordinate plane, which is very nice, and they're giving us the 2 points. So we're trying to find the distance between the point 25 and 40, 28. Pause the recording. See if you can work the problem out, and then resume the recording to check your answer. Here's our solution. You can find the length of the pass by finding the distance between the points. There's our distance formula. Plug the numbers in. Simplify. So we have 400 plus 529, which is the square root of 929. Which, when you put that in your calculator, you get about 30. Now again, normally when we have a square root and it doesn't come out to a whole number, we're going to simplify it but leave it in terms of the square root. But things like distances, again, it just doesn't make sense to leave it as a square root. It's a practical, real-life thing. How far are two things apart? You want to give a number or a decimal approximation, not a square root. So about 30 yards long. It also notes here that the scale along the goal line doesn't really appear on a football field. I'm sure you know that. However, when you use coordinate geometry to solve the problem, you can put the coordinate system in any way that's convenient to help you solve the problem, which is why they did that.